In the section Effect on relevant drugs, you will find a whole list of medications that might be used to treat the disease of the section that you're in. So in this case, for example, you see a long list of painkillers, so drugs that are used to alleviate pain. Now, with medication, the field of pharmacogenetics works like this. If you take a certain drug, for example, a painkiller, you swallow it and it goes into your bloodstream. Then usually your body will recognize that there is a substance in the bloodstream that is not meant to be there. And it is usually the enzymes of the liver that recognize this. So what the liver does is the enzymes recognize this drug, they chemically modify it, and this chemically modified drug is then recognized by the kidneys, and the kidneys then filter it out of the bloodstream and move it to the urine and eliminate it from the body. So this is the normal process, and this also explains why certain medication needs to be taken every day or maybe even 3 times a day, because the body absorbs it, it increases in the bloodstream, the body recognizes it and removes it, and then you take it again, it goes up and down, and by taking it in regular intervals, you end up with the drug being always in the active range within your bloodstream. Now, these enzymes that recognize this come from certain genes. So, for example, there is a liver enzyme gene called CYP2D6, which is responsible for recognizing and modifying and removing around 20% of drugs, of medication that is currently available. So, when you take a drug that is metabolized, we call it, recognized and changed by 2D6, the 2D6 enzyme recognizes it, changes it, and removes it from your body. Now, what can happen is that you might be born with 2 broken copies of this gene. So you do not have the enzyme that can recognize these drugs. So when a drug is taken, it goes into the bloodstream, but the body does not recognize it, and it stays there for a very long time. Now, if the drug is only taken once, it is usually not a problem. But there are some types of drugs which you, as I said, take once a day. So what happens in the bloodstream is it goes up, but instead of going down, it stays constant. And next time you take the next drug, it goes up higher. And then you take it again. And so the amount goes up every time you take the drug, and eventually it becomes toxic in your body. In cases of certain blood thinners, it can cause uncontrollable bleeding or very severe side effects. And this is why the FDA, the American Food and Drug Administration, also gives out warning for a lot of drugs that certain genetic variations can cause severe side effects when a certain drug is taken. And this is what we looked at here now. This is what we call pharmacogenetics, so how genes modify your response to pharmacology, to certain medication. Now, in this table, you see all of the different drugs, and I will talk you through this table now. So, for example, the painkiller alfenatil will, based on this person's genetics, have a normal effect. It is also possible that a drug might have no effect, or that it has a stronger effect than expected. So in these cases, all of them are normal. Breakdown is the speed at which your body, or the body at least in this example, recognizes the drug and then removes it from the body. Again, it is possible that it's normal, so it's 100% breakdown, it's recognized and broken down normally. It's possible that, as I said, the genes are missing, so it's not broken down, so it's down to 0% breakdown, so it stays in the bloodstream, or it can even be speeded up, so it can be broken down twice as fast. So what then happens is that the drug has a shorter effective span, and that might have to be counteracted. So based on this example here, the breakdown of this drug is twice as fast as normal, but the next drug is broken down normally. So the breakdown can be slower and faster based on genetics. So this drug here, for example, is only broken down 75%, and there's an example of 60% and 50%. So the last drug is only broken down 50% as fast, and if this drug were to be taken continuously, it would lead to increasing levels in the bloodstream and could then cause side effects. So the breakdown essentially tells you how quickly your body is able to clear it or remove it from the body. 100% is optimal, 200% is too fast, and below 100% is too slow. The likelihood of adverse reactions can also be estimated. Now, this only looks at breakdown. So if it's broken down too fast or too slow, adverse reactions are more likely. It does not necessarily compare the adverse reactions of two different drugs if they were broken down the same, but it will tell you something about to maybe look out for adverse reactions in drugs that are broken down at suboptimal rates. Here we go for the recommended dose. So if the drug is broken down twice as fast, the recommended dose to reach the same effect would be 200%. Now, please do not, under any circumstances, change the dose of any drugs that a doctor has prescribed to you. Your doctor can use this table to read up on your genetics, to know what to look out for, and he would usually, in this case, start with 100% of the drug dose and look for the therapeutic effect. If it's sufficient, that's okay, and he knows that he might have to go up to twice the dosage. But please, I say this again, do not under any circumstances change the dosage that a doctor has given you, but talk to your doctor about your different metabolic breakdown of certain drugs so that he might adjust the dose, or he might choose an alternative type of drug. And this is what the last column is for. So in this case, you would have to change the dose. So if there is an alternative painkiller, it would be advisable to choose an alternative. For example, this one, which is broken down normally. So looking at a few more examples, this last drug has a normal effect. So you would see a normal effect, normal pain-killing effect. It is only broken down 50% as fast. So if the normal dose was given, the amount would start to increase every time it is taken. So adverse effects would be more common. And to counteract the slow breakdown, it would be advisable to start with only 50% of the dose. Again, your doctor would then be able to start with 50%, see if there is a therapeutic effect. If yes, that's fine. If not, he can still adjust the dose. And again, in this case, an alternative would be advisable. So you will find this section in many of the centers that have drugs that are used to treat them, and it might be missing in others where simply there are no drugs that are usually used to treat the disorder.